So first thing that we saw, that Docker is actually nothing but a operating system level virtualization, using which if I want a machine, I can have a machine like environment on the existing laptop or a host machine. And in that, whatever that I can do on my host machine, I can do it inside this Docker or a container. And there is no restriction on where you will be running it. We can run Docker whether it could be a physical machine, or it is a machine on cloud, or it's a machine on virtualization concept itself. So everything will be working in the same concept. Okay, and we just saw in quickly overview on why exactly we need Docker, as in the advantages where now you don't have to allocate any specific RAM or the resources for it before you have to work. So on that concept, now let's try to understand exactly on what is the difference between the container concept and the regular virtualization. Because now when I say containers or Docker is all about operating level or operating system level virtualization, what exactly are we going to do and how is it different? Now, if you consider the traditional method of virtual concept or the virtualization, wherein we might be using some tools like VMware or Hyper-V, now what is that you will be doing? So let's say that now you have a machine, a host machine or a physical machine, which acts as the machine on which you're going to install on top of it. So let's consider that we have one such machine where it could be of a Windows or a Linux, anything. And in that, now you're going to install the software called as VMware or Hyper-V. So those softwares which will help us to do the virtualization is called as hypervisors. Now, using this, let's say you have installed VMware. Now, using the VMware, we can actually create different kind of virtual machines. Now, for each of the virtual machine that we create, what is that we have to do is, when you create a separate virtual machine using this tool, you will be having a complete operating system as if you are going to have a new physical machine. Just like that, you are going to have a complete operating system, and then specific to this, whatever the libraries or the files that you have, and if you want any application to be run on it, you will install on this virtual machine and then run. So that is how each virtual machine that you're going to create will be acting as a separate operating system, and for which you will be having a separate complete operating system. Like how you are going to create a new machine, which means a physical machine, same way it is going to have a complete set of operating system separately for this virtual machine. And for that, anything related in terms of the files and the binaries for that operating system you'll be having, and you'll be having the application on top of it. So like this, for each machine that you create, you will be having a separate operating system in terms of, let's say I want to create one Red Hat machine, then there will be a complete Red Hat machine operating system here. Then if I want to create a Ubuntu machine, then I will be having a Ubuntu operating system completely, and top of that, whatever the libraries for that operating system and the application specific to this. So this is how we'll be creating a virtual machine and giving it to a user to work. But the problem here, what happens is, first thing is, when you take as an operating system, it needs some resource, right? So when I say resource, it needs RAM and it needs some hard disk and the resources for running the hardware. So from where are you going to give? So since the concept is virtualization, whatever that this machine which is separate or a virtual machine needs, it will be taking it from the host machine on which it is installed. So let's say that for each of this operating system, you need some 20 GB of RAM, just an example. Now, for creating one machine, you need 20 GB of RAM. And again, for this also, you need 20 GB of RAM. And again, for this 20 GB of RAM, because you are having a complete operating system inside each one of them. So now, for each of this, when you need 20 plus 20 plus 20, that is 60 GB of RAM, it is going to basically take that 60 GB of RAM from the host machine. So now, if you want to have 3 machines on your laptop or on your host on which you are using this tool to create a machine, you need at least 60 GB of additional RAM along with the RAM that is needed for this machine also, because this is also operating system, right? So if it is going to take 20 GB of RAM, then you need 20 GB of this and you need 20 GB of each one of them. So that's how minimum you need 80 GB of RAM. But if you want to create one more machine, then once again on the host you need to add another 20 GB. That is how you can create one more machine. So like that, you will always have a resource crunch, wherein the more number of machines you want to create, then you are going to require the host machine with a very huge set of resources. So that is how you can create only as many resources that is available. Based on that, only the limited number of machines can be created. So that is one of the problem. And the second problem is, now let's say you have created a virtual machine and the user is using it. Now if a user is going to use only for a couple of hours, then the remaining time it will not be used, but as an operating system it needs to be keep running on. So that way the 20 GB of RAM, whatever I said, is still going to be used from this machine whether you are running something inside it or not. So that is how, even though the machine is idle, it will be still occupying the same resources from the host, because to run this as a separate operating system you need that 20 GB of RAM. Like this, as you have many number of machines, you are actually making sure that by allocating a specific space, whether the machine is under use or not, you're going to still use everything from the host machine. Now, the same time, if you want to run something on the host machine directly to do some other task, that will also consume some kind of RAM. So that is when, to maintain all those things, you have to add more and more resource, as well as there will always be going to be a resource crunch. And then, as yesterday I was talking, if you want to replicate an environment, let's say I have used one VM and in this VM I have done some task. If I want to duplicate the same thing, once again it is not an easier task in doing it using VMware or other kind of tools. So that is when we will be moving ahead to a better operating system level virtualization. So how is it different from the container concept or the Docker concept? So in Docker, you're going to work on a similar way, but the difference is, let's say you have your physical machine or whatever machine you have. So on that, you will be having a specific operating system. Now, on top of that, you will install Docker, where using the Docker, you're going to create something like a container. Okay, container is nothing but a box. So inside that box, you're not going to keep the complete operating system, but you're going to keep only those set of files which is needed to treat this box as an operating system, but not a complete operating system. That is the first difference, where inside the container, you are going to keep only the files through which you can recognize that box as a separate operating system. So that way, now in each of the box of the container, you can put some specific operating system related the basic files, and then if you go inside the container or the box, you will be working as if you are working on a separate machine based on what kind of files that you have put for that operating system. Suppose if you want to treat this container as a Ubuntu machine, then you have to put the very base file for the operating system, because every operating system will have a basic set of files. So that what we call it as bootable system. So if you put only that into this container, and then when we go inside the container, we will be working as if it is a Ubuntu machine. The same thing if I have one more container, and inside this if I put a Red Hat based bootable files, then this container will be treated as a Red Hat machine. So that is how, on top of that, whatever applications that you want, you can put inside it. So the major advantage now you see, like the previous or the traditional way of virtualization, you are not allocating any RAM for it, because you are not having a complete operating system. It is just only the bootable files of the operating system is available. So that is when If the same thing here you want to create 3 machines, you are just going to take a very minimum in terms of what you are going to run. That will be directly run on the process itself, that is on the host machine. So that is how you are not going to spend an space allocated to it. So this is the point here. So unlike the regular virtualization, in container, the resource that you are going to use is only for the resource which you are running inside the container, but not for a container directly. So that is where now you can create as many containers as you want. So there is no space or no resources allocated for it. Whereas you can treat each one of them as a separate machine, and whatever that you put inside it will be specific only to that container. And it is also easy to replicate, where if I just copy or make a copy of this container, and from that I can create one more new container where whatever that I had in this container, the new container will also have it. So that is how it's easy to maintain and replicate, and at the same time I can easily start or stop this container whenever I want. If I want to use, I'll just start it. When I don't want to use, I can stop. So there is no allocation of the resource or RAM in this. Okay, so that's the basic difference, where in the container you do not have the complete operating system, but only the bootable files of that operating system. Getting the primary difference between the normal virtualization and the container, and what's the advantage? Hello? Can you guys hear me? Is that clear, the difference? I'll talk about it, Karnakar. Let's first understand the concept. So is the concept clear? What is the difference between a normal virtualization and a container? Okay. So now, when I said that, when you create a container, what is that exactly you're going to put inside? But before that, let's try to understand what do you mean by container in the generic way. So it's actually, you can compare this to a shipping company. Now we know that how do we do export and import. So basically one of the method of transportation for that is shipping. Now when you have a ship, and in that you would like to send some or export some goods. So now for the same shipping company, there will be product like you might send rice, and you might try to send some raw goods like iron, and you might also send something like dairy products. Okay, now when you have different things to put, how is that you're going to ship everything into the same ship? Because now if I have everything related to rice, I need to have a separate environment for it, right? The temperature and the moisture content should be different. Same way, if I'm trying to send a dairy product, then I need to put it under a freezer. So that is how, just for one, I cannot put everything into a freezer, right? I cannot make the whole ship into a AC compartment. So that is the first requirement that I said yesterday or in the previous class, that if you have different requirements, how is that you're going to adopt? So that way, you can see the solution. What the shipping companies have done is they don't put everything together. So basically the ship will be just plain. On top of that, you put boxes. Okay, and boxes by boxes, you will be putting the content. So that is how these boxes are called as containers, where now you can use a specific container for storing some particular type of goods. So now if you want to ship certain dairy products, then you can have only as many containers as you want, and inside that you can have the specific freezing or whatever option, and then store everything. Then on top of it, I can create one more container and I can have specific rice related or raw goods. So that is how, rather than putting everything into one, you can create containers where on a particular container you put whatever that is needed and then you try to do the export or import. So that's how all in the movies you would be seeing, whenever they show the shipping, it'll be a huge rectangular box called as containers, which they will be transporting, where you will be using specific containers inside which you will be having all a similar kind of product or goods that you want to ship. Same way, now if you take the operating system concept, now a container is nothing but a box, you can assume, where you put whatever that you want inside it and it will be used as a separate machine. And unlike the normal virtualization, what is that you're going to put? Now each container or a box has to be treated separately like a unique operating system. So that is when I said inside it you will be putting certain operating systems bootable file. So using that, if you go inside the container, it will be treated as a separate operating system. So that way, what is that files that you put regarding to a operating system? So basically, that is the image of an operating system. Okay. So in Docker, for every operating system, you will be having a image. So now, if I create a container like an empty box, inside that empty box, if I put a particular image of the Docker, then after putting the image, if you go inside the container, it will be working as a separate operating system. So if I want to work on Red Hat, I will create a container which will be empty, and inside the container I'll be putting a image of the Red Hat, so that if I go inside the container now, we will be working as if it is a separate Red Hat machine. Same way, if I create one more container and inside that if I put CentOS Docker image, then using this image file, when you go inside the container, you will be working as if it is a separate operating system. So that is how you will be using this Docker image, and by which the container will be treated as a separate operating system. Okay. So what exactly does the image contain? That is what we need to know. So the image, when I say it is a specific Docker image, it is not like any other operating system image. So it will contain layers of layers on top of it. Okay. So if you say that you have a particular Docker image, now in that the base or the first layer that you have will be the bootable file system of that operating system. So only through which it will be recognizing or treating the container as a separate operating system. Okay. So that is the first layer that you will be having. Whereas on top of that, whatever specific files or applications, whatever that you install or configure, will be as a separate layer on top of your bootable file system. So that is what an image will be basically consisting of. So if you want to have a deeper understanding, you can consider the Docker's image is nothing but an operating system without a kernel. So now when I say operating system, by default, it will be having a kernel, which is the one which will be doing all the processing. So every operating system will have a kernel, which is the heart of the operating system. And that is the one which does all the processing on what to do and when to do and how to do. Okay. So that way, whatever the image that we are going to use in the Docker is actually an image specific to the Docker, in which you will not be having the kernel, whereas the other things, whatever is needed to treat the operating system as a unique operating system, you will be having certain files, and that is what you will be having in an image. So that is what a Docker image is, nothing but a complete operating system minus kernel, because only if you have a kernel, it is going to be treated as a whole operating system and you need all the resources for it. If not, we can just consider the image, that is a Docker image, as an operating system without a kernel. Okay. So now if you say that you are working on Docker, it's all about creating a container, which is nothing but like an empty box or an empty processes, and inside which you will have to choose a particular image of an operating system where you want to work, and corresponding to that, you will have to put the Docker image inside it, and then when you go inside the container, you will be working as if it is a separate operating system. Okay, so that's how images, it's all about different layers put together, where it will be having the boot file system as the first layer, which will not have the kernel, but other than that, whatever files is needed to understand it as an operating system, you'll be having it. Okay, and thereafter, anything that you try to install, configure, or store in that container will be stored as a layer by layer on top of the image. Getting it? Yes, getting it? Karnakar, Satish, Vinay.
Hey Adam,
Yes.
actually we will install this Docker on a physical box, right?
You can install it
First.
physical box or on a existing virtual machine also.
No, what I'm asking, like, if first we will install on physical box Docker. After that, we'll on the top of Docker we'll install the containers, right?
Yes, Docker is just an software which will help you to create containers.
Containers. Docker is help to create the containers.
Yes.
Okay, got it.
So inside it, now you will be using this image through which only we will be treating it as a separate operating system.
Okay.
Now, how does the Docker work? So for that, let's first understand what are the different components that you will be having in a Docker. So basically, when you install Docker, it is all about having two components in it. So first thing is, what is that you install and handle everything? So those are called as the core components. And for your activity that you want to do some task where you run some commands, those are called as workflow components. So when you say the core components, when you install Docker, it is actually a Docker daemon which you will be installing on a machine. Okay, so that is nothing but an agent or an engine which will be actually doing all the process that we need. So if you say you are installing Docker, basically what you install is a Docker daemon or a Docker engine. That is the one which will be running on a particular machine where you have installed. Okay, and that's the one which will be trying to do the task whatever that we have. Then Docker client. What do you mean by Docker client? So Docker client is the utility through which we will be connecting and giving the specifications to the Docker daemon. So Docker daemon on the background, it will be taking care of all the processing, and whatever that now we connect and the commands that we use, that is called as the Docker client. So basically, Docker client will be taking the input from us and it will be giving it to the Docker daemon and process it accordingly. Okay, so those are the two parts. Then the next thing is you will be having the workflow components. So in the workflow components now, if you say that you want to work, it's all about creating different kinds of containers. So that is what the Docker is going to do. In which, what exactly is a Docker container? A Docker container is nothing but, you can consider it as an empty box or a particular content of an image is what you'll be having, because now logically if you think, you cannot have an empty box. Okay, as of now, to understand, I was saying you can consider it as a box. But in terms of a machine, you cannot create a container empty. But basically, when you create a container, it is not going to have anything. But as in the concept, when you create a container, it is the location where you will be putting some specific operating system's image, and top of that, you will be working. So that is a separate space for you in the current host machine. So that way, a container has to have an image along with it. So that is how, when you say that you are going to create a container, you need to specify what image that you are going to put inside it. So that is how container is represented as the runtime instance create from the image. So based on that, you will be saying what is that you are going to do inside and how separately it will be treated. And basically, when you're working on Docker, it's all about starting a container, stopping a container, or restarting it so that whatever that you have inside, you will be able to access it. And in that way, what do you mean by a Docker image, which you will be putting inside a container? So a Docker image is nothing but a template which will be having a particular set of environment and some applications in it. So environment means it will be having first the bootable file system of a particular operating system, and then on top of that you will be having specific files on which you will be working. So that is how, when you create a container, you will be saying what image you want to use, so that inside the container that specific image will be put, in which you will be having a specific operating system's bootable file system, using which you will be treating it as a separate operating system and then work on it. Okay, so that's how container and images are closely coupled together. So now for a container that I'm creating, I can choose what kind of image I want to put inside it. Based on that, the container will be treated as a separate operating system. So if I put Ubuntu's based image, then it will be treated as a Ubuntu container, because the common term is container, but if you go inside the container, it will be treated as a Ubuntu operating system. Same way, if I create a container and inside that if I put a CentOS image, then that container will be treated as a CentOS machine. Okay, so that's how you put a image inside a container, and based on that you will be working on it as a separate machine. Then now in Docker, it's all about creating the containers and putting some image. But if you see, we can create our own image if it is needed. So that is how you can replicate everything. That I'll be talking about it later. But now, when you say that you are going to create all the containers, where are these containers going to be stored? So these containers are going to be stored in the Docker daemon or the Docker engine. In the same way, we will be having different kind of images. So specifically for Ubuntu, you might be having many things, or for CentOS. So where are we going to store all these images? As well as, if I need, we can create our own image. So these things will be stored in a place called registry. So a Docker registry is nothing but a location where we will be storing all the Docker images. Okay. And there are two types of registry. One is public and the other one is private. So by default, if you are trying to create a container, you need some image to work, right? So you can use the Docker's open source community, and they will be having a specific registry from which we can download whatever the standard image which Docker gives, and we can use for creating machines. So that way, if you are using those open source related images, then it is called as a public repository where everyone can access. But if you are creating an image specifically for our organization, we cannot put everything into the open source. So that is when whatever registry that we are going to create and maintain will be called as a private registry, where we can use it only within the organization. Okay. Then there is one more term called as Dockerfile, where just now I said, if we want, I can create my own image and I can use only that. So that way, if you are trying to create your own image, you can do some steps manually. If not, it's always better to automate that also. So that is how we have one more concept called as Docker file, in which it is going to act like a script where if you want to create an image, you tell that all the details, and that Docker file will be helping us to create an image specifically. So that's how we will be using this Docker image generation using this Docker file. So like this, these are the components that we have majorly in Docker. So using all of this, we'll be doing some regular activities. Okay, getting it? Before I move on. Karnakar, Vinay. Okay, so now with these components, let us try to understand what is the architecture of the Docker and how exactly now it will be working. So primarily now, if you say that you have installed Docker on a particular machine, then from that machine, you will be using the Docker client. So whatever the Docker commands that we are going to run is basically the Docker client, which is going to help us to run some command, and that will be passing it to the Docker engine, where Docker engine will be taking care of everything. So that way, when you want to first work on your machine, you will install Docker, and using Docker, when you want to create a container, you need to have some specific image using which you will be able to create a container. So for that case, now from the public or the private registry specific to your organization, first thing what you can do is you can try to pull the concept of the specific image that you want. So if you want a base image of Ubuntu, then from the registry, whatever you have, you can try to download it, or you call it as a pull. So that way, if you try to pull a particular image, using that, you will create a container. Okay. So when you're creating container, using the same image, you can create as many containers as you want, where each of the container will be treated as a specific operating system. So that way, it is not that when you create a image, you have to specifically create only one container from it. So using an image as a reference, you can create as many containers as we want. Okay, so everything will be having the same copy of the files in the image. Okay, so like this, when you want to work specifically, first you have to pull a particular image that you're going to work on from the registry, which could be a public or a private key, inside our Docker engine. And then using that, we will be creating a container where inside the container, it will be taking a copy of your image, and using that, whenever you go inside the container, you will be treated as if it is a separate operating system based on the image what you have specified. Okay. Now, like this, I can create as many containers as I want from an image, and in that, I can define what I want to do, and if I go inside it, based on this image, it will be treated as a separate operating system. Now, if needed, what we can do is, we can create a new image from the container. Okay, so that is how, if any other person who is going to use this image, whatever that you had here, everything will be available on this new image. So that is how we can make copy of our containers as an image, and now if anyone uses this image, he will be getting everything under his container. Okay, so then once it is done, pretty much, if you want to store it or share this particular image with others, then you can push it to the Docker registry. So that is how you are going to build an image whenever you need and put it to the registry, from where others can use it and create a new container. Okay, so that's how, if I want, I can create a separate image from any one of the containers. And for a container, you can start or stop or restart based on what kind of access that you want to do in it. Okay, and then as I said, in case if you want to create an image file but you don't want to create the image file manually because it contains a lot of steps, then you can think about automating the process of creating a container, or from a container an image that you want to create, that we can automate it using a scripting language or a concept called Dockerfile in Docker. So in this, you will tell what and all are the details you have to put, and based on that, it will be creating our own image if I need to use it. So that is how, using the Docker file, you will automate the process of creating a image. Getting it? Okay, let me put you a diagram which will be more clear. So now let's consider, now let's say that you have a particular image. Okay, now in this image, let's say you have put specifically now one operating system's bootfs. Okay, so okay, now let's say that this is a image. Okay, so in this image, what you're going to have, you're going to specifically have the bootfs of a particular operating system. So let's say now you have Ubuntu's bootfs. Okay, so you have Ubuntu's bootfs. So because of this, now if you go into the container, it will be treated as a separate operating system, that is Ubuntu. Now on top of that, in the image you can have certain applications, whatever you want. So let's say that I have some application. Okay, so this is what is an image. Basically we can consider that way. This is a image, a base image. We don't just call it as an image, but as a base for a container, this is the image that we'll be using. So now if I create a container will be empty. So inside it, the first thing what you will do is you will use a particular image and put it inside. So now what will happen is, if you put it like this, when you get a new container, inside the container, now if you go, it will be treated as a specific operating system. Okay, so that is what we are going to do here by treating it as a separate operating system. Now in that, because of this image, you are going to treat it as a Ubuntu container or a machine, and inside that, whatever applications that you have, you will be able to access as long as you are inside the container. Okay, so this is the general step where I can create a particular container in which I will put an image of a particular operating system. Based on this, if we go inside, it will be treated as a separate operating system. Now, on top of this, if we need, we can put whatever applications that we want. Okay, so let's say I create one more layer on this and I put some specific files. Okay, or I can say there is another application that you want to install and work. So I can install some specific application on top of this. So like this, you continue using this container as long as you want. But if I want to share the same thing with someone else, what I can do is I can create a complete container from this. Sorry, I can create a complete image from this. So when I say I'm going to create an image, from this I can create an image where whatever the content that you have inside the container will be taken directly to treat it as an image. So now from this, if I create an image, you will be having the bootable file system of Ubuntu, and then you will be having application 1, and then you will be having application 2. Okay, so that is how now we can have many different layers. Okay, and then I can have here. Okay, so here now this will be your Ubuntu's bootable file system, and then you will be having app as well as whatever that you had here on top of that on the container, that will also be here. Okay, so that is how from this container I can create our own image, and from this image if I create a new container, so it will be empty, right? Now if I create a new container and inside that if I specify this image, so all of them will be exactly put it here, right? So that is how now if I go inside this container, I'll be treated and I'll be working as if it is a complete Ubuntu based file system. So that is how you can create a container, and from that you create an image, and going forward for a new container, if you use this image, then whatever that is available in that image, everything will be coming here. And then on top of this, we can try to put some specific files or changes which will be known only to this container. So that is how from a particular container you can create an image, and you can use this image for, or you can share this image with everyone, wherein it will try to put into the container and then it will be working as if it is a separate operating system. Okay, so this is what happens basically when we try to what create a new container from a image, or from an image, sorry, from a container you can create a separate image that we needed so that it can be referred at any point of time later. Getting it on how a container works and how do you create an image out of it roughly? Vinay, Satish, Karnakar. Okay, fine. Now try to understand only the logic. Don't get too much into the technical part. I'll try to show you, but first you need to be very clear on what exactly is Docker and what are the components and what exactly happens when you work. Okay, so is that clear so far now? I was just talking that if you say you're working on Docker, you will install Docker, wherein if you say installing, it is a Docker engine which you are installing, and then you will be using a Docker command line, which will be the CLI or the client, which will be interacting between us and the Docker engine. And then it is all about creating different containers, where inside the container you will have to put the image of a specific operating system that we want, and it is not a complete operating system image, but it will have only the bootable file system and not the complete kernel. So that is how we can create a container and put the image inside it, so that if I go inside the particular container, it will be treated as a separate machine. And if needed, from that container, whatever the content you have, I can create a new image. And if anyone else is creating a container and if they use the same image, then whatever that I had in my container will also be available as a copy for them in their container. Getting it? Others? Is that clear? Okay. So now, with this understanding, let's try to work and see how it is going to behave. So first thing what you have to do is install Docker. And when I say installing Docker, you are actually installing the Docker engine. And it will also contain a Docker client in it. Okay. Now, earlier, Docker used to come as an open source, but now Docker also has their specific enterprise version where you will be having certain more features. Okay, so if you want to work on Docker, you can use the Docker Community Edition. That is the open source one which you can download and work without paying anything. Okay, so Docker comes in both the flavors, enterprise as well as the Community Edition. So when you're working, first, what we have to do is practically, you need to first specify to the operating system on where is the location of the Docker from which you want to download. Because unlike the older methods of downloading some specific file and working, nowadays all the applications use a concept called omnibus, where you will be just giving a location of where is that particular files for an application that is available related to the operating system. Automatically it will be downloading it from that respective operating system's mirror, that is what we call, or the site. Okay, so that way in my place I am going to use the Red Hat based operating system or CentOS. Okay, so the only difference what you'll be having is, if I'm trying to run everything on CentOS, the operating system command that I'll be using is yum. Specifically, if you have any other machine like Ubuntu, then you're going to use a command called apt-get. So that's the difference. So the command wise operating system to system will be different, but the concept what you're going to do will be the same. So as an example, I'm just going to quickly show you on how do you set it up on a CentOS machine. Okay, first let's try to connect. Okay, now this is a machine which I have connected. Okay, now in this machine, if we first see, so this is a CentOS machine, just to verify. Okay, so now whenever you are trying to install something on a Linux machine, then we always have to be the root user into it. So that is how you will be getting all the privilege on installing or uninstalling. If not, you can have a separate account called as sudo users. So in Linux, we have a separate group of users called as sudo users, that is sudo. Now, if you want to have all the privilege similar to root, then what we can do is, there is a specific file for this, where if I add a username to it, then that user can do all the things like a root, wherein he will be having the root privileges. So that is how, when you go to an organization, you will not be given the root password, but they will be adding our account or a common account into this sudo list, where using that common account or our account, we will be able to run certain things which is needed, which will be exactly equivalent to the root privilege. Okay, so try to make sure either you have the root access to it. If not, we have our users added to the sudo user list. Okay, so we'll be seeing all these things in terms of sudo users on the later module, but for now try to log in as a root. Suppose if you have a machine, try to log in as the default root, so that you will have all the permissions to install and do certain activities as an administrator. Okay, so first thing, I'm going to switch the account to root. So root is the administrator on Linux, like how we have on a Windows administrator username. In Linux, we will be having a account called as root, which will be having all the privileges equivalent to an administrator, or in fact, this is the administrator account on Linux machine. Okay, so now I have logged into a machine, and this is the name of the machine, and I've logged in as a root. So as the root, we are going to run certain commands. So the first thing what we will do is, we will install whatever is the dependencies for this particular operating system. So that is what the first thing that you're going to do. So if I say yum install yum utils, I'm installing all the utilities that is needed for this operating system. Basically, first you have to make sure the operating system libraries and all the other required files are up to date. So that is what we are going to do as the first step. So it is saying that for our operating system, all the packages or the libraries are up to date. So there is nothing much to be done. In case in your machine, if it is not that, it will try to download certain files and install those packages as needed. Then the next thing is, now when I say to the operating system install Docker, from where it has to pick it up, it needs to know, right? So that is when we are going to give this specific repository from which the CentOS operating system will be downloading the particular Docker and it will be installing it. So that is how this particular command is going to tell to the operating system that if I say install Docker, you are going to refer to this site of Docker and from there install the specific Docker what I am going to say. So that is what we are trying to give the location of where is the repository for the Docker if I have to install it. Then go ahead and install Docker, where Docker-CE is nothing but Docker Community Edition, which we are trying to install. So now when I say install Docker, it is going to go to this particular location that we have given as a repository, and from there it is going to install Docker on our machine. Okay, suppose if you have already installed Docker and if you run it, it will upgrade it to the latest version in case if it is an older one. If not, it will say that you have already installed Docker, nothing much has to be done. So that is how, if it is already installed and it is an older version, it will update. Suppose it is the exact or the latest one that you are working on, then it will not do anything. Okay, so once you run this, you would have completed installing the Docker. Now in Linux, if you install anything, basically we call that installation as a package. Okay, so after installing, in order to use it, we have to basically run that particular application or the process related to it. So that is how on Linux we use some word called as service, where service is nothing but the operating system should be able to automatically start or stop. So that is how for each package or application that we create or install, we will have to create a service for the system only through which we will be able to start or stop or restart that particular package or application. So that way, for Docker, we will have to create a service and then we will be starting that service where internally the operating system will be trying to call the particular Docker engine and start it. Okay, so that way, to start the service specific to Docker, you will be saying Docker, that is service start Docker or systemctl start Docker. So this means now you are going to start the service of Docker. So if you want to see this, if you use the same command and instead of start, if you say status, it will tell you whether it is running or not running and what exactly it is running. So here you can see that the service of the Docker has been set up and then it has started running. Okay, and when it is running, it is actually trying to create so many processes and it is trying to listen for the users to work. And the other way you can cross check is you can do a ps-ef and grep for the processes which is running, and you can see that the same thing it is trying to show where Docker has started running, wherein the D represents the daemon. So there is a Docker container daemon which is running, using which we will be able to create different kinds of containers. Okay, clear so far? Okay, so now we have installed the Docker, wherein it would have installed two things, that is two components. One is the Docker engine and next the Docker client. So now whatever that we are going to work, basically we will be using a command called as Docker, which is nothing but the Docker client or the CLI. So using this, if we pass a command or an option, this will be talking to the Docker daemon that we just now saw and process whatever the data that we want to work on. Okay, so that way the CLI what we are going to use is nothing but this called as Docker. So where is it exactly? So it is installed under bin. Okay, so this is the CLI or the command line utility using which we will be interacting with the actual Docker daemon, okay, or the Docker engine. So now once you have installed Docker, to verify, if you just run docker info, then it will be giving you the complete data about how it is running and what is your system properties that it is trying to utilize. Okay, so you can see here it is going to give you the complete details about what is your operating system, what and all details that it is trying to use from it. So if you get an output clearly like this, it means that Docker is working or the Docker engine is working properly. Okay, so now what is that we have done? We have installed Docker. So the next thing is it's all about creating different kind of containers, and for that we will be using the command called Docker, which is nothing but the Docker CLI through which you will be interacting to the Docker engine or daemon. Okay, so now before we get in, the first thing that we need to know is how is that you are going to create a container. So to create a container, you will be using a command called as docker run. Okay, so whenever you execute this command called docker space run, then on that Docker engine, the Docker will create a container. Okay, every time, remember, every time you execute this, you are going to create a new container. Okay, remember, a new container. Then when you are creating a container, you need to not just create a empty container, but you have to associate an image to it. So that is how when you create a container, you will be putting a specific image based on which the container will be treated as a particular operating system. Okay, so one of the mandatory option that you're going to tell to the docker run command is what is the image that you want to use specific to the operating system. Okay, so you will say docker run and give an image. So now what it will do, it will try to create a new container, and in that whatever the image that you have specified related to that, it will try to put the files. So then if you go inside the container, it will be treated as a specific operating system based on this. Okay, is that clear? So you will say docker run and the image name. Okay, now when you are creating a container and inside that you are specifying a image. So when you say docker run image, what is that you are doing? You are creating a container and inside that you are going to put some image, and this itself will be running as a process in your host operating system. But after creating the container, you want to go inside it, right? Because as of now, whatever that you are going to do, basically you can see that I have connected to this machine using this terminal session. This is nothing but a terminal session using which I am connected to this machine. Same way, this container which we are going to create is also acting as a separate operating system. So now in order to connect to this, we need to assign a terminal session. So that is how, unlike a separate operating system, we are not going to do a SSH and connect, but for our current terminal, we can attach the container. So after creating the container, we will attach the same container to our terminal. So that is how we will be going inside the container. Okay, so in order to attach our current terminal to the container, what we will do is we will try to specify an option called as T. So T represents the terminal. So what happens here is we will create a container and in that container we will put a specific image, and after that our command prompt or the terminal session will get attached to the container. So that is how we will be going inside the container as soon as you create the container, because without T you cannot connect to it. Now, after connecting to it, you are supposed to do some activity inside it, but still we have just connected to it, wherein it is not a full operating system. So that is when, in order for us to interact inside the container, so whatever that we say, the container should be accepting it. So for that, you will give one more option called as -i, where -i represents interactive mode. So you are not just connecting your terminal to the container, but you are also telling to the container that you want to have the terminal in an interactive way. So you can give it separately, or you can simply give it as -it. So now by running this command, what we are doing, we are creating a new container based on this image, and after creating, we will be attaching our current terminal session to this. So that's how you will be creating a separate operating system, and you will be going inside it and you will be working on it. Okay, so that is what you're going to do by the first command, that is docker run -it and the Ubuntu. So here you will be giving the name of whatever image that you want to use. So as of now, when you're starting your work, we don't have any specific image with us. So we can try to use the standard images, whatever the Docker itself will give us. Later on, we can create our own image. But to get started, Docker itself gives us certain standard template kind of image, where it is the bare minimum, or we call it as a base image. It will not be having many files. It will be having only the files by which you can treat it as an operating system, only the bare minimum. So you have to install everything on top of it, and you can create your own image. So that way, for the first time when we are working, we will be using a image that is a base image which Docker is going to give. So by default, the name of the base image will be the operating system itself. So if you want to use a base image for Ubuntu, you will have a name like this. If you want to use a base image for CentOS, then you will be having it like this. Okay, so for now, since we are working on, since we are completely working on CentOS machine, now let me try to use a Ubuntu image, so that using the Docker container, we will be virtualizing a Ubuntu machine. So now the host machine is going to be CentOS, whereas inside the container, if we go, it will be as if it is a separate Ubuntu machine. Okay, so the first command that we will run is docker run -it, the name of the image which you want to pick up. So now here I'll say docker run and -it and the name of the image. So I'm going to use the Ubuntu image. So this is the default or the base image for Ubuntu operating system. Now, when you are working, as I said, the image is not present on our machine. So the first thing what will happen is, when you do not have an image available on your Docker engine, it will try to get it from a Docker registry. So that way, it will be trying to take it from the public registry, or the Docker's open source or community edition registry. So from the community edition, that is the public repository or registry, it will try to download that image to your Docker engine which is running on that machine, and using that you will be creating the container. So if it is already available on your Docker engine, it will use it. If not, if you are giving an image name, and it will try to search for the public registry by default, and it will try to download from there. Okay, so you can see now it is saying that it is unable to find the image called Ubuntu. So the first thing what it will do is, it will try to download this image to our Docker engine, and then it will create a new container with the base of that. Okay, Now, after creating, what is that I said? You are going to basically attach your current terminal to this particular container, right? So that way, if you look very closely, this was the actual host machine on which I ran this command, correct? But after creating or running this command, you can see that it is not showing the name of our machine, wherein if you say host name, it will give you the name of your operating system or your machine. You can clearly say that this is not my machine on which we are working. And what is this operating system? So there will be a file called etc under etc os releases, I'm trying to say. Now clearly it says that we are working on a Ubuntu machine, that is 16.4 Ubuntu. So what is it? This is our container on which we are working. So what we did is we created a container. Inside that we told to put a Ubuntu base image, and because of which we directly attached the session or the terminal to this container, and because of which now on top of our machine there is a container running and we are inside the container. So you can see now this is a specific container on which we are working. This is not our host machine. Getting it? And how do you come out of your container? Because you are still attached to the container. So now whatever activity you want, you can do into it, because you are going to work on a separate operating system, wherein this is a container on which you are working. So after you have done all your work, if you do a exit, if you see the screen very closely, it is coming out. So it is coming out of your container and it is coming back to your host machine. You can see this is my host machine, and correspondingly so this is CentOS. So that is how whenever we ran the Docker run, it will always create a new container, and in that container you will be attached if you say -it. So if you don't say -it, it will just create a container, but you will not be attached to it. Whereas if you say -it, it will create the container and we can attach to it. And for that, it is trying to use a specific image called Ubuntu. So that is how, as soon as you go inside the specific container, it will be treated as a separate operating system. Okay. So to cross check, I'll show you something. Now this is on our host machine, right? Host machine means the machine on which we are working, and top of that we have installed Docker, which is a CentOS machine. Now if I go into the temp folder, you can see these are the contents on your host machine, just to make sure that this is not the same machine inside your container. Okay, and everything is separate, correct? So now if I say Docker run -it, and once again if I say Ubuntu, it will create a new container. It is not the container which we created long back. It is going to create a new container and we will be attached to it. So right now if you see, the image is already available in our machine. So quickly it created a container and we are inside it. And what is the name of the container? This is the container. So this is not our host machine. As well as if you look at the files, you can clearly see that it is a Ubuntu machine because of the image that we have put inside it. And now here if you see, it is going to be treated as a separate operating system. That is how you will be getting a complete separate file system. File system means the complete directory structure, and in that if you go to the temp, you can see that there is nothing, because we are not on our host machine. We are now inside this container which is based on a Ubuntu image. So that is how, until we are inside this container, it is going to be treated as a Ubuntu machine. So if I create anything here, Ubuntu container, it is going to be treated. Now you can see this is available under our temp. So as soon as if I say exit, it will come out of it. And now if you see, we are back to our host machine. And here, if I do a ls of my temp, you can see you're not seeing it because this has a separate file system, whereas inside your container you have a file system. Whatever that you are seeing is separate. So that is how inside the container we are going to treat it as a separate operating system, that is Ubuntu machine. So like this, for each container you can choose a particular image based on which you will be working on it as a separate operating system. Getting it? Hello? Others? Vinay, Nagesh, Satish. Right? Now, if you look at this, going back to the basics of Linux. Now, what exactly happens when you connect to a machine? So if you recall, for every operating system when you connect, you will be having a specific shell based on which you will be running everything, right? So as a user, when you log into a machine, what and all happens? It will be going to a specific home directory, and then there will be a specific shell that is being assigned to you, correct? So that is how, starting with this shell, you will be running all the commands inside it because it will be giving you an environment. Same way, if I'm creating a container, even in the container, I should be having a specific environment from which I can start running any command I want, correct? So that way, when you are creating a container, you will be next passing a command or option which will be the entry point to the container. So now, when you say entry point, after you create a container and attach yourself, what is that the first thing that you want to run inside the container? That is what you are going to tell it here. Okay, so after creating the container and putting the image, if you attach yourself to the particular container, what is that the first thing that you want to run, so that from thereafter you will be doing all the activity. So that is how, whenever we are running the container creation, you will specify a particular shell, so that if I now say docker run -it, and let's say if I say Ubuntu, and if I say bin bash, it means create the container based on this image and attach to it, where you run the first command as bash, so that now this container will be having a bash environment, so that now whatever commands that you are going to run inside it will be using this bash environment or shell. Okay, so let's do it once again quickly. Docker. Okay, if you have noted, every Docker container that you create will be having a unique ID. That is how the Docker engine will be keeping a track. So you can see this is a unique ID. So now if I create docker run -it Ubuntu and let's say bin bash, it is going to once again create a new container which will be having a different ID, because each container is specific and different. So that is how, just like how you are going to have a machine name, for each container you are going to have a specific ID. And then now if you do echo $shell here, you can see you are actually using this bash. Not only that, if you do a ps-ef, you can see the only process running inside your container as of now is this bash shell itself. So that is how, this is the first command or the entry point, what is that you want to run after you create a container. So after creating the container, it has run this shell, and that is the process what you're seeing. And in fact, this is the same shell on which we are trying to work. Okay, so that's how the option that you give is after the container, you will be giving the entry point or the first command that you want to run inside the container. Okay, clear so far? Any questions? Okay, now until now, what is that we did? We basically created almost 3 different containers, correct? So when I say every time I execute Docker run, I'll be creating a new container, wherein now we have created 3 containers. So if you say you are creating a container, and as soon as if you say exit, you are going to come out of the container. So you can see here, I am still inside my container, but if I say exit, I am going to come out of my container. Yeah, that is understandable. But if you create a container, you will be doing some activity, but it is not just one-time activity where you will say exit and come out. The purpose of creating it, whenever you want, you should be able to go back to the container, correct? So that is how what happens now is, as soon as you enter exit, you are actually losing the connection to the container, where what happens is, if you say exit, you are going to come out of the container to your host machine, as well as the container will be stopped. What do you mean by stopped? When you want to access a container, it needs to be running as a process using Docker engine. But as soon as you come out of it, it literally means that you're not going to use it anymore. I mean, not using in the sense you have come out, which means you're not using it now. So that is why automatically what Docker will do is it will stop running the container. So that is how you can make use of the process effectively. But the concept here is, if you come out of the container, you are actually stopping the container. And now, if needed, we can go back to the same container at any point of time. Okay, so that is how you can create a new container. When you come out, you're going to stop the container, and at any point of time, you can restart the container and go back to the same container. Okay, so that is how you can start, stop, and restart a container whenever you can. Whenever you want. That's the concept. So that way, now, if you want to identify a container, it is always little difficult to understand or remember this name, correct? So every container will be having a unique ID like this. So it is not easy for us to remember. If you go up, you can see this is one unique ID, and before that, whatever we created, you can see it is also having a unique ID. So if you want to reuse the same container, you have to remember this, which is a difficult task. So that is when, while creating a container, what you can do is, you can use an option called -name, and you can give a name to it, whichever that you want to remember, so that whatever the name that you give here will be used for our reference, whereas the Docker is still going to create a unique ID like this. But if you want to refer to this container, either you can refer it using the container ID, or you can use the name whatever that you have given. Okay, so that is the purpose. You can give a particular name to a container so that you can easily remember and handle it whenever you want. So that way, let's try to create a new container and we will name it. So simply I'll say name, and I'll say test container. same options. You see, I'm adding more and more options to it. So now it has created a new container, but whenever I want to refer to it, I can use this name and Docker will help me to reference to this container ID. Okay. So to show this, now I'll go inside the temp folder, and you do not have anything in this, right? So I'll create a new file and I'll put this file here. So I'll say container dot this ID, just to understand that we are creating a new file which is available inside this container with the same container ID. Okay, so this is what I've done. So now if I do an exit, I'll be coming out of the container, correct? So if you want to go back to the same container, now the first thing what you have to do is we need to start this container, because as I said, if you do an exit, you are coming back to your same host machine or reattaching the terminal to the host machine, but you are going to stop the container. So that is how, if you want to go back to the container, as of now it would have been stopped, so you have to start the container. So to start the container, you will be using the command called docker start, and either you can say the name of the container ID or the simple name that you have choose to specify the container. Okay, so now if I say docker start, I can use this name, and you can see now it has been started, but we have not yet attached to it, because remember, if you want to attach to the current terminal session, we have used the -t option, but here it is already a container which has been created, so we are just starting it. So in order to go to the container or attach our terminal, you will be using the command called as attach. So starting is separate and attaching is separate. So now if you say docker attach and this container ID, you can see we are back inside this container. And if you go to the temp folder, you can see that you are pointing to the same container. So let me just come out. So if I exit, now you are back to your host machine. Just to refer, you can see the contents is not same. Now if I want to once again start this, I can say docker start and I can refer this name. So now instead of the container ID, I can use the name also. So I've started, and then we'll say docker attach and this. So you can see now we are back to the same container wherein we are referring to this name, and you can see we are getting the same file. So that is how you can identify or refer a container either using a particular container ID, or you can give a name to it and you can refer to it using this. And whenever you come out of a container by doing an exit, it will stop the container. So if you want to get back to the container, you will first start the container and then attach your terminal to the container. Getting it? Any questions? Is that clear so far?
Adam, this docker start test container, if that command is given, if the docker, the container is started, right?
Yes.
What are, the attachment is for that the connection bit. I didn't get.
See, start means you are just running the container, because what happens when you say exit, the container will be stopped.
Okay.
So by saying start, you are starting the container, but you are not going inside the container. Starting is separate and connecting is separate. So if you want to connect to the container, then you have to say docker attach. So that is how it is going to connect to the container and you will be working inside the container.
Okay.
Getting it?
Yes, yes.
Yes?
Yes, yes.
Nagi, Karnakar, are you able to follow? I didn't get, what do you mean by that? Is there any chance of losing the images inside the container? No, 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 no. See, when you create a container, you are not putting the image. You are just taking a copy or a reference of the image and you are putting it. Okay. So the container now is a complete operating system. So the question, how it is, let's say you are having your laptop. If you go inside the laptop, can you separate your operating system from your laptop while you're running? No, that is not going to happen. So when you say container, it is just a box or it is a process. Only when you put the image inside it, you are actually giving a more meaningful purpose for it. If not, it is nothing but an empty box kind of stuff. Getting it? So that is how anything that you put inside a container, you actually act accordingly. Others? Okay. So we saw how do we start a container, and when we come out, how will we stop it? How can you give a name to it? And whenever you want, an existing container can be started and you can attach yourself. Correct? So when you say container, it is most flexible where if you want to run something inside it, you don't have to always connect to it. Because now let's take an example. I want a new machine to run some application. So basically, let's say that I have some application which I want to keep running, which others users want to use. So for that, what will you do? You will create as a, let's say if you create a machine, inside that machine you will be installing some application, and then you can just disconnect from that machine, whereas the machine will be still running, and inside that whatever the application that you have will be still running. Correct? Ideally that is what will happen. But if you're replacing that machine with your Docker container, what will happen? Because now when you create a container, you are attaching to the container, and after attaching, let's say you install this application, and if you run the application will be running. But as soon as if you do an exit, what will happen? The container itself will be stopped, right? Because of this, the application, whatever you are going to run, will also be stopped. So what is the solution that I can do? So that is when you are trying to run the container, you don't have to always attach it. But if you have a requirement where the container has to run something and same time it should not be working on an interactive mode, so then you can run the container in a mode called demonized mode. Demonized mode means you will be creating the container, and in the container, if you want to run anything, you can run inside, but you will not be attached to it. So that is how you can just create a container and run something inside it. So without connecting, because the problem is if I connect to it, I have to do an exit to come out of it, and whenever I do exit, it will be stopping the container. So that I want to do. So what I want is I can just create a container and run whatever I want to run inside it, so that without us interacting with it, it will be directly running the container in the background, and it will be trying to run the application or command, whatever that we are running inside it. So we can make use of the demonized mode in that way. Okay, getting it first of all, what is the demonized mode? So simply what I'm saying is I need a machine and I want to run something in the machine, whereas I don't want to connect to the machine, because as the concept of container, if I connect or attach myself to that, it will be trying to exit, and when I exit it, it will be stopping it. So that is how, if I want to run something, whereas without attaching to the container, if I want to run, then instead of the -it here, -it, now I can use something called as -d. So if I say -d, instead of connecting our terminal to the container, it will be running the container in the background. Okay, so to that, now if you give some command here, it will run that command as well as it will be running the container in the background, so that we can happily run or create a container, as well as inside it you can put some specific application or whatever that you want to run. Okay, so let's see an example, but before that I'll just show you one simple one-liner where, so this is a one-liner shell script. Okay, so what it is going to do, it is going to basically wait for every 1 second, it will be just simply printing hello world. So it is just a one-line script where if you run it for every 1 second, it will be running on an infinite loop. Why do I need it? So if I put this inside the container, I can know that container is running something inside it. Okay, so just an example. So let's come out of this. This is on my host machine. So if I run this, so every 1 second it will be printing. So this is one infinite process which I can run now, just for understanding. So now let's create a container and pass the same thing to it. So now if I say docker run -name, so let's say daemon container, the name for it, and then I will say -d, so that we are not attaching our terminal to it, and then we will say what is the image that we want to use, and then followed by that, what is the command or the entry point that you want to run. This is the one. So what it is going to do now, it is going to create a new container and name it as daemon cont, and in that it will put a Ubuntu based image, and then it will be keep on running this inside it. Okay, so now you can see we didn't attach to it because we have not used the -it. So what it is doing, it has created a container and it is running it. Okay, so how do I know whether this container is running or what exactly is the container running inside? Because if I have attached my terminal to it, we would have seen the output on the screen. But when it is running in the background, then you can make use of a command called as logs-f. So if you say docker logs-f and the name of the container or the image, it will basically try to show you whatever is running inside the container on this screen. Okay, so now if I say docker logs-f and this name, so you can see now whatever is running inside this container as a live output, it will be showing on our screen. You can see it is continuously printing it. Getting it? So that is how, if you want, you can basically run the container without attaching in the background, and you can pretty much run it anything. So if you want to see what and all is running on your Docker engine, if you say docker ps, it will give you the list of what and all are the containers currently running. So you can see now currently on our machine we are running one container called daemon container, and that is running this command, and this is the image of it, and based on it this is the particular ID that it has assigned. Okay, whereas if you say ps-a, it is going to give you a list of all the containers which is available in our machine currently. And in that, what is the status? You can see the status of all the containers is exited, because as soon as we attach and we say exit, it is going to stop the container. Whereas this container that we are running now is running in the background as a demonized container, because we have not specified -t. Getting it? On what do you mean by a demonized mode? So that now it is not mandatory that you always have to attach to a container to run something. You can just create the container in the background and you can run whatever that you want inside it without attaching. So that now, as long as we want, we can keep running some application or whatever. And in that, if I want to see the output, I can say logs-f. Okay. Getting it?